Yeah, 7-4, 7-5 are super easy. It's just use a formula, and that's pretty much it. 7-3 is a little more complicated, so let's start there. Because we're solving actual equations using the unit circle, so you got to know, be comfortable with the circle and your functions. So let's open the stuff here and stuff. Let's start out with something simple. So solving trigonometric equations. Okay, so solve for sine theta plus 7 equal to 9. The first thing I'm going to have you do is on part A here. It looks like a 9. Part A. Solve on one period, or I should say, solve on 0 to 2 pi. So your angle theta is between here. Because technically, you can keep finding solutions over and over by spinning around the circle forever. So unless we restrict it, you will have an infinite number of solutions. But let's get there. Let's solve this first and see what I'm talking about. All right, so whenever you're solving trig equations, isolate the trig function. Get everything else out of the way. Subtract the 7. Right, 7 minus 7, or 9 minus 7 gives me a 2. Divide by 4. So sine theta is equal to 1/2. I skipped some of the algebra here. You guys cool up to this last point. Isolating sine. Okay. All right. Just let me know if you need an extra step there. So at this point, there's a couple ways to think about it. I say pull out your graphing calculator just in case, because it's not always going to be pretty numbers or a scientific calculator. So technically, this is on the circle. Let me open up the circle file too, just in case. Okay. So what does it mean when you're solving a trig equation? So right now we have sine theta equal to 1/2, right? So basically they're asking you what is theta. So when is the sine equal to 1/2, right? See right here, you can see it. The y value is 1/2 when sine is at 30 or pi/6. So you can technically just find the answer really quick by looking at it if it's a pretty answer. But if it's not a pretty angle, like let's say this is a number that's not on the circle, you'd have to do it this way. Let me show you the step first. Do sine inverse of both sides. So then these cancel. Theta is equal to sine inverse of 1/2. And that's when you use your calculator. Second sine, make this brighter. the second sine of 1/2. So that's just going to be 30 degrees. So this is 30 degrees, or pi over 6. Either one. So what you're supposed to do to find the other one, because remember how we said inverse trig functions only give you solution in the right half of the circle. So we have two solutions. Let me show you the answer. Right. So we could see this one right away. So another one, when is a y value 1/2? That would be over here. You see what I'm saying? So there's two of them. So the way you find the second one is you subtract from 180 whenever you're using sine inverse. So one answer is this guy. The other answer is this. So there's my two answers. Okay. Any questions on how we solve the trig function? You're basically isolating the trig. You're isolating the trig function and then solving for theta. That's all you're doing. So these are the two answers in one period.
Can you go over the second one again? The
Right here?
like how we got 150?
Yeah. So whenever you're using an inverse sine like this, to find the other one, just subtract from 180 degrees. So you take this one, the one you found over here, and just subtract from 180. That'll give you
Okay,
the other
thank you.
angle every time.
Okay, my computer froze. Thank you. Appreciate it.
Yeah, no worries. So that's for one period. So once you've done it for one period, doing it for all theta, so solve for all angles, right? All you got to do is tack on this repeating piece, and before we do that, let me show you what I'm trying to say. Right, so you agree that if 30 degree was a solution, right? If you add 360, that's another solution. Add another 360. You see how I can do that forever and keep landing here, and I still keep getting a half. So that's an infinite number of solutions. I can keep doing that forever. So what you do is you take the 30 degrees that you found and add 360 times n, where n is an integer. And then you take the other one that you found over here, the 150. Then you tack on 360 n. So basically 1, 360, 2, 360, 4, 360, right? N can be any number. I keep going around and around, negative or positive, and I'll get all the angles. So it's easier to find this one first, the one period, and then just expand it. Are there any questions on part B?
So if it's asking for like that, where would that? I think I've seen some of this homework because I tried it and just didn't get it. How would it ask for that stuff? Like, and how would I present that in the way that made sense? Would it give me an integer then to plug in? And if I did, how would that look?
Well, I think eventually.
Sorry, I don't mean to be too concise. I'm sorry.
No, you're good. You're good. So eventually, you're gonna have a problem where you can have many solutions in one period. So you're gonna have to plug in some numbers for n. But it depends on the original function. Like if it wasn't just, if it was a sine of 2 theta, then it's repeating itself faster within one period. So you're gonna have to find more solutions using this. So sometimes it's easier to find this first and then come back here and figure this out. But let's look at the questions in the homework real quick. See how they phrase it. See right here, they solve for a random equation, and then they say, well, this is just, they didn't tell you one period. So they want you to use an n as an integer. So the answer is going to be pi thirds, right? Or 60 degrees plus 360n. So I'm going to keep spinning around and landing at pi thirds or 2 pi thirds. So you'll solve it like we did, and you're going to get these two answers, and then you tack on 360n. Okay. So same thing
Cool, I
here.
get it, yeah.
So 4, 5, 6, 7, 8, 9, all these are going to be what we just talked about, just in varying, just a little different. This x over 2 might be different. If you end up with a double angle, it might be more difficult, which we'll do in a second. But that's the gist so far. But we'll get there. Let's do another one. You guys cool on this page? Okay. Okay, so let's go ahead and solve it. Solve for one period, 0 to 2 pi. So divide by 8 and get to here. This reduces. That gets us to 3 over 4. Square root both sides will get us a plus or minus, which will create multiple solutions. So cosine would be equal to plus or minus square root of 3 over 2. So anywhere we have a positive or negative root 3 over 2 will be a solution. Okay, so let's just use our circle this time. Oh, where is it? Can you see the circle? I think it was there a second ago. Okay. So cosine is the x value. So this has a square root 3 over 2. So that's one of them, pi over 6. There's another one over here because it's negative, so 5 pi over 6. So pretty much either one, positive or negative, are going to be answers. So we have this one, this one, this one, this one. So it looks like 4. The first theta I'm going to use radians this time, get away from degrees. Pi over 6. Theta 2 will be 5 pi over 6. Write them all down. Theta 3 is 7 pi 6. Theta 4 11 pi 6.
Can you switch screens back?
Yeah. All right. You guys see where these came from, right? Or no? So they all came from the circle. Okay. One moment. All right. So now for all solutions, right? So if they don't tell you one period, then you're going to assume they want all of them. Okay. If all they give you is this, solve this guy, they're expecting this, part B. So theta 1 will be pi over 6 plus 2 pi n. Theta 2 is 5 pi over 6 plus 2 pi n. Pi 3 or theta 3, that will be 7 pi over 6 plus 2 pi n. Space theta over 4, or theta 4 would be 11 pi 6 plus 2 pi n. Okay. So we can probably condense these, right? I mean, this might be fine on your solution. But if we look at the circle, right, we have 4x, so pi over 6 and 7 pi over 6. You see how that's just 180 degrees or pi radians away from each other? Right, this one and this one are solutions, and they're separated by 180, right? This one and this one is also separated by 180. So I can just condense these to adding pi, because adding pi gets me to here and to here and to there over and over again. If I start there, add pi gets me to here and here. So I can actually just have 2 solutions instead of 4 by condensing it. Does that make sense? So what I'm saying is you could write this as well as pi over 6 plus n pi or pi n. Because pi n will hit 7 pi 6. And then you can use 5 pi 6 and add pi n to get, this will hit pi 6 and 11 pi 6. You see what I'm saying? So either one of these are technically right. This is just nicer. I think they're probably, I think they, I mean, I would accept both, but the homework might want this one. So I'm looking at an example right now, problem number 8. Check this out. It's almost the same as ours, except they have a half at the end instead of a square root 3/2. Notice how they only have two pairs of solutions, and they use pi n pi or pi n. So yeah, they condense these two. Anyway, any questions on this? Okay. I say we do problem 8 just to be sure. Example 3 would be problem 8. You guys cool if I turn the page? Let me know if you need me to slow down or something. So 4 cosine squared theta, or I guess they use x, it doesn't matter really. I'm gonna stick to theta. -1 equals to 0. Isolate cosine. Divide by 4. Square root both sides. You got to tack on the plus or minus whenever you square root. So cosine theta is equal to plus or minus 1/2. So we're going to write down all the angles as to where that happens. So in case you missed the algebra, +1 got me to here. Divide by 4 got me to there. Square root both sides got me to here. Any questions on the algebra before we move on? Yeah, let me know. So cosine equal to plus or minus 1/2, that's asking for what are the thetas that have x values of 1/2. So we got this one, -1/2, -1/2, +1/2. So 1, 2, 3, 4. So just like the last one, I'm going to write down those angles. Pi thirds is the first one. Next one is 2 pi thirds. Pi 3, sorry, spaced out for a second. 4 pi thirds. And 5 pi thirds. These are all these solutions. So we need to condense them. So here's one of the answers, right? If I add pi, no, I don't. Well, where is it? Yeah, if I add pi, I'll hit this one. So instead of saying pi thirds plus 360 or 2 pi over and over again, I'll just say this one plus pi, 2 pi, 3 pi, 4 pi. See how any pi would get me to one of these two. Once I'm already here, if I add pi and pi again, I'll keep landing there. So once a true solution from the homework says that I should write down pi thirds plus pi n. And then the other one is going to be this one plus 2 pi thirds plus pi n to get this one. So 2 pi thirds plus pi n should get me both sets of answers. Are there any questions on that? That's how they're getting this here. And so everyone sees why it's pi n. Okay. Guess you guys are all badasses. That's good. All right. Let's move on to something else then. Number 9. So we'll stay on this section a little longer, but let's do questions that are a little harder. Because so far these solutions have been just basic algebra, right? So the main idea doesn't change. Like all this stuff here is the same. The stuff that's going to change is this step here, just slightly change. So for example, so on the homework, they don't tell us one period or anything. I just need you to see how you would do it either way. But okay, so cosine cubed minus cosine is equal to 0. So treat this just like you would like any factor problem, right? Factor cosine out of this stuff. So now I have cosine squared minus 1. And when you have something factored, you can set each part to 0. So cosine equals that. Square root both sides, and then I'll give you plus or minus 1. So the question is, okay, what angles give me a 1 and a negative 1? What angle gives me 0? So the first angle, x1, let's look at the circle. Right, so what makes the x value 0? That's going to be pi over 2 and 3 pi over 2. Okay, now if you would have used the calculator, let's say it wasn't a pretty number on the circle, you would have said cosine inverse of 0. Then you would have got 90 degrees. And then you do 360 minus that answer to get the other one. So 290 and 270 are the answers because I'm in degrees, right? Pi over 2, which is 90, and 270. See how they're right there? So when you're doing cosine, you subtract from 360 or 2 pi. When you're doing sine inverse, we said subtract from 180. So just remember that if you have to, if it's not an angle on the unit circle. But the first one is pi over 2. Second one is 3 pi over 2. Third one is, so that's these two for this first one. Now, where are we 1 and -1? We could do the calculator again, or just look at your circle. 1 and -1. So 0 and 180. I'm sorry, pi. So those are the 4 solutions, but we have to combine them or tack on the n pi stuff. So do you agree that these answers are all on the 4 corners of the circle? Right? 0, pi over 2. See how they're on the corners? And you guys come up with a formula will make you land here, 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 over and over again.
N plus pi.
Let's see. N
No, yeah, I'm sorry.
pi, it'd be, well, you see, what's the distance from here to here? Hey, between each corner. how
1/2.
much- Yeah, right. Pi over 2 or 1/2 pi.
Sorry.
So yeah, I think that would be it. That would be the answer. And n pi over 2. 0 n pi over 2 gets me here. 1 pi over 2 gets me there. 2 pi over 2 is a pi. 3 pi over 2 is right there. 4 pi over 2 is 2 pi. And I can keep doing that. You see what I'm saying? That's where this answer comes from. In the homework. This is problem 9. That's why they just simply wrote n pi over 2. They didn't write my 4 solutions. Even though my answer is true, they combine them with this, because this will land on all 4 over and over again forever. Where n is 1, 2, 3, 4, 5, 6, all the way to infinity, or 0, -1, -2, -3, till -infinity. So it'll just keep going around and around, landing on those 4 corners here. Does that make sense? How they get those solutions?
The like getting the solutions based on the unit circle and finding them makes sense. The algebra kind of did like confuse me there for a second, like what you did once you had factored out cosine, like there's 2 sets of equaling zeros or something like that. I don't understand what you did there.
So this right here, when I set 2 things to 0,
Yes.
so that's just a property from back in the day. Whenever you have, it's called the 0 factor property. Whenever you have a times b equal to 0, you can always set each part equal to 0. Because if a times b is 0, then one of them has to be equal to 0, or both of them are. So you try to figure out and solve. So once you factor, that's why whenever you do quadratics, that is why you set it to 0, because you're trying to factor and set up the situation here. That's why you've been doing that forever. You know what I'm saying?
That makes more sense now.
Like when you had like something like this, right? Then you're technically setting each part to 0, then you'd get 2 answers. So I thought I had 4 answers that can be represented by pi over 2n. So this is what they want. This will make you land whenever whenever you choose any n, you'll land on one of these 4 spots where n is an integer. Okay. Let's say we do one more. Let's do problem 11. The quadratic type. And then we'll move on to 7.3. I'm sorry, 7.4. You guys cool on this page? Let me know. We can turn it back. Now, if it helps you, you can rewrite these as, you can do a substitution just so it makes more sense in your head. You could say let W equal cosine X. Because you've solved things like this before, right? So factor this guy and then bring it back into factor this and bring it back to cosine. And I'll skip the factoring step. You end up with 2w minus 1 plus w plus 1. Once you're factored, set each part to 0. So you get w equal to -1 and 2w equal to 1, which means w is 1/2. Of course, w is meaningless because we made it up. So replace w with cosine. That's what it's supposed to be. And then find out what angle gives you -1.5. Right? Any questions on the first algebra step here? You see how it's the same stuff, but it's the algebra is getting a little bit more complex. But when you get down to here, we're back to the circle stuff. Okay, let's look at the circle then. The algebra is cool then. Where is cosine -1? That's going to be at pi. It's the only spot. Where's cosine 1/2? That's going to be pi thirds and 5 pi thirds right here. So the answer would be x1 is pi plus 2 pi n. X2 would be what did I say? Oh, 5 pi thirds. Yeah, pi thirds plus 2 pi n. X3 is going to be, we said 1/2. Where's the other one? 5 pi thirds plus 2 pi n. That'll be your 3 answers. just tack on the 2 pi n if you can't condense them. And that's how they're going to get these 3 answers. Any questions on 5.3 or 7.3? All right, let's move on to 7.4 and 7.5. These are super chill. I'm just gonna use a formula. That's it. So let me write down all 6 formulas, or maybe 8, and then we'll start. You guys okay on this page? Any last minute questions here? All right. 7.4. Sum and difference. Formulas. Number 1, I'm going to use alpha and beta for my variables. So alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Number 2, cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. Number 3, sine alpha plus beta is equal to sine cosine sine alpha cosine beta plus cosine sine alpha beta. Number 4, sine alpha minus beta that is sine alpha cosine beta minus cosine alpha sine beta. Number 5, tangent alpha minus or plus beta. That's going to be tangent alpha plus tangent beta over 1 minus tangent alpha tan beta. The other one will be exactly the same, just switch the pluses and minuses here. Alpha minus beta is equal to tan alpha minus tan beta over 1 minus tan alpha tan beta. Oh, side note here, real quick. Might as well write it down now. We're writing formulas. cosine of pi over 2 minus theta is equal to sine. And sine of pi over 2 minus theta is equal to cosine. All right. Let's pick some examples. All right, so this is problem 4 from your homework.
Hey, can you hold on? Can you wait up? I'm writing. I'm trying to catch up.
Yeah,
I'm
yeah.
sorry.
Yeah, no rush, man. Just let me know. I'll wait a sec. Just tell me anytime. So the homework is going to start out just basically quizzing you on these formulas, like the first 3 questions. And after that, you're actually going to use the formulas.
Yeah, y'all may as well score. Yeah, we're good to go.
All right, first example will be problem 4. Find the exact value. So these questions are going to require you to actually do the work. Calculators will only give you approximations. And either way, it's not that hard anyway. You're going to give you something like this. All right, so this is like the alpha and beta. So if it has a sum and it's cosine, we'll use number 1, right? Number 1 had a plus. So number 1 says this will equal to cosine alpha, which is the pi over 4, times cosine beta, which is pi thirds, minus sine of pi over 4, sine of pi over 3. So at this point, just look at your circle and figure out, okay, well, what is all this stuff?
Points on the unit circle.
Yeah. Pretty much, that's all we're gonna do. So cosine pi fourth is the x value. So write that one down. So this will equal square root 2 over 2 times cosine pi thirds. That's the 1/2, right? 1/2 minus sine of pi fourths, which is this one. Square root 2 over 2 times sine of pi thirds, which is square root 3 over 2. So you just get these numbers from the circle. Multiply this out. Multiply this out. And that's pretty much all you can do. You can combine the fraction, I guess, but that's it. See, pretty easy, right? Just use the formula and find the points. there any questions on how we found the points or anything, or?
Yes, real quick, this is, I think I'm kind of not understanding something. I just want to make sure. Sine would be a projection onto the y-axis, correct?
Yeah,
Okay.
yeah, so.
Now it all makes sense.
There's
I have to
this-
write that down for the 5th time.
No, it's all right. So sine of pi force means what's the y value at pi force. Cosine at pi force means what is the x value. And etc. You just write them all down. And that's where this nonsense came from.
Will we be back on campus on Monday, Professor?
Yeah, we'll be back on Monday.
Okay.
Okay. I also extended all the homeworks for you guys.
Thank you.
You think you have about 2 more weeks or so, or maybe a little less.
Thank you.
When it comes to the test, what does that mean? That
Probably have to. I don't. When does the test close? I don't even remember. Let's see, I don't think I've put a due date on the test.
Thought it was in April.
Yeah, I didn't
I
see a
should
date in
see.
Canvas when I checked.
Yeah, there's technically no date. I need to choose one, I guess, but let's see here. The syllabus technically wants us to be done with that sometime. Actually, it's supposed to be this week, I guess, but that's a little early. So I'll put it towards the not this weekend, but then the next weekend. No, somewhere around there.
And you said it's going to be similar to the test number 1, right?
Yeah, similar format. But it's based on the review. So we'll probably do review next week and answer homework questions, and then let you start doing the test at some point.
Okay.
Are you guys good on part A here? Okay, so just a quick note. I'm gonna make a space over here. Just for emphasis, this is not the same as part A. So that'll be square root 2 over 2 for this one, and that'll be 1/2. See how they're not at all the same as this, right? So you have to use your formula. This was my alpha right there, and this was my beta. Here. So this is the first few types of problems you're going to see. Then you're going to see something like this. You guys cool on this page? Okay. They give you an angle that's not on the circle, something weird, but you can adjust it. Let me write the instructions first. find the exact value of cosine 75 degrees. So what you do is you break it up into two pieces, a sum of angles that are on the circle. Let's use the small one first. Because 30 is on the circle, and so is 45, right? You see how I can break this up? So this is my new alpha and beta. So then just apply the formula. It's going to be cosine alpha, cosine beta, minus sine alpha, sine beta. So find them on the circle and you'll get this. This would be what we found earlier, pretty much. Very similar. Square root 6 over 4 minus square root 2 over 4. Any questions on number 2? You see how we set that up?
Yeah, this is like way easier.
Yeah, the 7-4 and 7-5 are very, I think, pretty chill. This is a little harder, but not really. Find the exact value. See how this one is in radians, so it's hard to like visualize it unless you're like a badass with fractions. How to break it apart.
Oh, what?
A
Did you
badass
say refractionist?
expert fraction guy. Fractionist. Let's see. So 3 pi over 4 plus pi over 6. Did you guys see that in your head? Nah, I didn't, right? That's weird. So if you did, that's great. But what you could do to avoid this weirdness, it's just convert it. Convert it into degrees by multiplying by the conversion factor. This will cancel. We get 11, 180 over 12. What does that reduce to? I got 165. So now, is this easier to break up? What two numbers would you choose that are on the circle? And there might not, sometimes there could be two answers. If you look at the circle, 120 is right here. If I add 45 to it, I would get 165, right? So I could use 45 and 120. Unless my math's wrong. Right, is this equal to 165? Do you see how this works? So if you're ever stumped, you can always convert it and use this. instead.
So why did we choose 45 and 120, other than the fact that they just add up to 165?
Because those are on the circle. That's the only reason.
And they're just easy because they're on the circle and they break up like those, just those two things, one they equal 165 and two because they're easily like identifiable on the unit circle.
Yeah, because otherwise we can't use the exact values on the circle. They got to be
Okay.
on the circle.
All right, that helps. Thank you.
So this is my alpha now and beta. Use your formula. So sine of alpha, sine cosine. Cosine. Plus cosine. Alpha, beta. You could have picked another set technically. That's all good. This would be square root 2 over 2. So cosine of 120, I don't know what that is. I think you can see it got the circle. It's negative half plus square root 2 over 2 times that guy, which will be square root 3 over 2. So that'll give me negative square root 2 over 4 plus square root 6 over 4. Which I guess one more step would be 1 fraction of root 6 minus root 2. So this is an exact answer. No decimals. Any questions on example 3? All right, let's do one more example. We'll call it a day. On Monday, we'll do 7-5 and then review for the rest of the week. Next week. This is problem 13 from the homework. Were you guys cool on the last page, right? So this is a little more difficult. They're going to give you two pieces. Sine u equal to negative 3/5. Cosine v equal to negative 15 over 17. They're going to ask us to find cosine u plus v, which is equal to this on the formula. Cosine u cosine v minus sine u sine v. Okay, look at the homework. Number 13. Yeah. So the note they also give us is both u and v are in quadrant 3. Okay. Quadrant 3, both x and y are negative, which is why sine and cosine are negative for both sine u and cosine v. So what you're going to do is build two triangles. One triangle for u, another triangle for v. So opposite, adjacent, or opposite over hypotenuse, right? This is gonna be 4 because it's one of the magic triangles, or you could do Pythagorean theorem and it's gonna be 4, but negative because it's in quadrant 3. Cosine V adjacent over hypotenuse. Do your Pythagorean, and this would be -8 because quadrant 3. I skipped the Pythagorean step. Given 2 sides, can you find the missing side? Do you have any questions on this? Do you see how I built the triangle using this piece here and then built the other triangle using this piece? And you'll notice I cannot use this formula because I'm missing what? Cosine U. I only have cosine V. And I need sine V to finish this. That's why I had to build this triangle. That's why I did this. Once you have it, find sine U. Right, that's already given to us, so that's right there. Cosine U. That's adjacent over hypotenuse. Now I go to this guy. Sine V, opposite over hypotenuse. Cosine V, adjacent over hypotenuse. So now I found all the pieces I need. I can just plug them in. And you're done. So cosine U plus V is equal to cosine U times cosine V minus sine U times sine V. There we go. And that's it. Do this multiplication and you're done. Negative to negative is positive. 4 times 15, what is that? Well, actually, these reduce. It's 3. Negative 12 over 17 minus. These do not reduce. 3 times 8. 5 times 17. I don't know what that is. $85. Is your screen still frozen, Michelle?
It unfroze, but like your screen went like super tiny for some reason.
Let me
I'm in full screen.
let me try to redo it for you here, just in case.
It says your Jack Gonzalez's network bandwidth is low.